Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the examples in the EM wave characteristics. That is the fifth unit. The last unit, electromagnetic wave characteristics examples. Okay. The first example. So the example can take, I'll explain the whiteboard. A 300 megahertz, a 300 megahertz uniform plane wave propagates to the fresh water, propagates through fresh water for which alpha is equal to 0. The given alpha is equal to 0, that is nothing but attenuation constant, and mu r is equal to 1, and epsilon r is equal to given 78. Then they are asking to calculate the attenuation constant. These are not the alpha, my dear students, is sigma. Calculate the attenuation constant. Attenuation constant alpha. Second one, phase constant beta. Phase constant beta. And third one, wavelength lambda. Wavelength lambda. And fourth one, intrinsic impedance eta. So these are the three, or the three is the four parameters you have to find out for the given function. The frequency 300 megahertz of uniform plane wave propagates to the fresh water, for which the conductivity is 0, mu r is 1, and epsilon r is equal to 78. So to find the attenuation constant, first of all, the given medium, see the wave propagated through the fresh water. They are saying it is a fresh water. In that, the conductivity is 0. The conductivity is 0. Assuming that the conductivity is 0 means that is a lossless medium. Lossless medium. Okay. So if the lossless medium is, what is alpha is equal to 0. And conductivity is a fresh water for which the sigma is equal to 0. The conductivity is 0. The attenuation constant, there is no any lossless medium. It is alpha is equal to 0. And second one, they are asking beta, the phase constant. The phase constant, whenever the propagation constant, we know what is the propagation constant? Gamma is equal to alpha plus I beta. Alpha plus I beta. This is a propagation constant. In that, whenever if it is a lossless medium, alpha is equal to 0, then the beta is equal to omega root mu epsilon. Okay, that omega is 2 pi f, and under root of mu is a mu naught and the mu r, and epsilon is a epsilon naught and the epsilon r. So we know mu r epsilon r, and the remaining the mu naught and the epsilon naught is a constant. Mu naught is equal to 4 pi into 10 power of minus 7 is always is a constant, my dear students, and it is epsilon naught is also the constant, 8.854 into 10 to the power of minus 12. Okay, and given the frequency is 300 mega, so 2 pi into 300 mega is 10 power 6, 300, and under root of mu naught is a 4 pi into 10 power of minus 7, and if mu r is equal to 1 multiplied with epsilon naught 8.854 into 10 to the power of minus 12 is epsilon naught, and epsilon r is given as a 78. Multiply this is 78 here. Okay, you can simplify this function. We'll get the beta is equal to that is a 55. I'm writing directly the value 55.529 radians per meter. Okay, this is a 55.5. So we got the beta. It is a lossless medium. Alpha is equal to 0. That's the first one. And beta is equal to 55.529. And the third one, they're asking find the wavelength lambda. And the lambda, we know the formula of the lambda is equal to 2 pi by the beta. 2 pi by beta. So 2 pi by, we got the beta is a 55.529. That is equal to, I'm writing the value directly, the 1131 meters. Because it is a lambda, wavelength is a length in terms of the meters. And fourth one, they're asking to find the intrinsic impedance. Eta is equal. Intrinsic impedance eta. Eta is equal to mu by epsilon. This is a formula. The under root of mu naught and the mu r by epsilon naught and the epsilon r. So what is a mu naught? 4 pi into 10 to the power of minus 7, and mu r is a 1 whole divided by 8.854 into 10 to the power of minus 12 multiplied with the epsilon r. Epsilon r is a 70. Okay. Under root. So here, by using your calculator, you can find the value. The eta we got as 42.656. Here the eta is intrinsic impedance. Impedance means the ohms. Okay. So alpha, the lambda we got 0.11 meters, and eta we got the 42.656 ohms. Alpha is equal to beta is equal to, and the wavelength lambda and the intrinsic impedance eta. Got it, my students? And similar way, coming to the next example, go for the second example, example 2. A 9,375 megahertz uniform plane wave is propagated in a polystyrene. So previous example, this the uniform plane wave is propagated in the fresh water. When the second there, the conductivity is given, the sigma is equal to 0, epsilon r is given, and the mu r is also given. In this, the uniform plane wave is propagated in a polystyrene the uniform plane wave in propagating in polystyrene if the amplitude of the electric field intensity, amplitude of the electric field is given, that is a 20 volts per meter, amplitude of the electric field intensity 20 volts per meter, and the material is assumed to be lossless, and the material is assumed to be lossless. Whenever if it is saying the lossless means alpha is equal to 0. Lossless, then find what they're asking, attenuation constant to alpha. Second one, phase constant beta. And third one, wavelength of the polystyrene, lambda. And the fourth one, velocity of propagation, the v. And asking the another one, the fifth one is the intrinsic impedance. Sixth, propagation constant gamma. And seventh, amplitude of the magnetic field intensity. Amplitude of magnetic field intensity. Okay. For that, the given mu r is equal to, for the polystyrene, mu r is equal to 1 and epsilon r is equal to 2.56. Okay. Now you can do by using this given data. The frequency is given 9375 megahertz uniform plane wave is propagated in a polystyrene. If the amplitude of electric field intensity given, E bar is equal to 20 volts per meter, and this material is assumed to be lossless. They are saying it is a lossless directly. The first one, alpha, the attenuation constant alpha is equal to 0, since it is a lossless medium. Lossless medium. Got it, my students? Then the second one, the beta, the same formula you have use mu epsilon under root omega into, that is equal to 2 pi. The frequency is given 9375 mega into 10 power of 6 and under root of mu naught and the epsilon r, and that mu naught and epsilon r is a mu naught 4 pi into 10 power of minus 7 into mu r is a 1 multiplying with the epsilon naught 8.854 into 10 power of minus 12. Okay. Into, and what is the epsilon r is equal to here? 2.56. 2.56. That is equal to, what is the formula here? The omega into under root of mu epsilon. Then directly I am writing the value here, 3314.37. The beta is in the radians per meter. And third one, the same formula what we used in the previous example to find the wavelength lambda is equal to 2 pi by the beta. 2 pi by the beta. So 2 pi by beta we got as a 314.37. That is equal to lambda is in meters. So 0.01998 meters. Got my students. Now the fourth one they're asking is the velocity v is equal. velocity V in terms of the lambda is equal to V is equal to F lambda. Is a formula, my dear students. These are very, very important. So directly by substituting the given values, if you know the formula, okay, the velocity is equal to 93375 into 10 power of 6 or the 10 power plus 6 into 0.01998 is the velocity F lambda. Okay, the F is directly is given the frequency 9375 into the power of 6. It's the frequency one, directly given the frequency megahertz. Okay, that is equal to, we got 1.873 into 10 to the power of 8 meters per second, the velocity. And the fifth one, the previously find the eta is equal to under root of mu by epsilon. Okay, that is equal to mu naught into mu r for pi into 10 to the power of minus 7 into 1 whole divided by epsilon is 8.854 into 10 to the power of minus 12 multiplying with epsilon r is a 2.56. Got it, my dear students? Simplify by using your calculators, we'll get the 235.46 ohms. And sixth one, they're asking gamma is equal. What is a gamma? Propagation constant is alpha plus I into beta. What is alpha? Attenuation constant. Due to the lossless medium, alpha is always a 0. 0 plus I into the beta is a phase constant. We got a 314.37. Okay, is an imaginary coefficient per meter. J into 314.37. And other one they're asking, it is a seventh one is amplitude of the magnetic field intensity. Amplitude of the magnetic field intensity. We know the intrinsic impedance is related with the EM by HM. EM by the HM. If this electric field is always in the X direction, so it is represented as X. Magnetic field is in the Y direction, it is a Y. Okay. You need to find the HY, the eta is equal. What is the eta? We got 235.46 is equal to, the electric field is given the 20 by the HY. That is equal to HY, that implies HY is equal to 20 by 235. Sorry, 235.46. The value is when you calculate this one is a 0.08494. The electric field is a volts per meter, and now the magnetic field is amperes per meter. Okay, so totally the 7 parameters they asked to find by the given frequency, and the uniform plane wave is propagated in a polystone. For that material, assume it is a lossless and r is equal to 1 and epsilon r is equal to 2.56, and given also the amplitude of the electric field intensity bar is equal to 20 volts per meter. They ask the attenuation constant. Given that the lossless of medium is alpha is equal to 0, and the beta is equal to omega into under root of mu epsilon, and lambda, the wavelength is pi by the beta, velocity is f into lambda or F lambda, and intrinsic impedance is equal to under root of mu by epsilon. Gamma is a alpha plus I beta, and eta is a EM plus by the HM plus, or otherwise the electric field is in the X direction and the magnetic field is in the Y direction, EX by the HY. Therefore, the HY, the amplitude of the magnetic field intensity, we got the ratio between of intrinsic impedance with the electric field intensity amplitude. Okay, my dear students. Now coming to the next example. But they are actually another example, third example in the fifth unit. An electromagnetic wave in a free space have a wavelength in a free space. Free space they're asking is epsilon r is equal to 1. Electromagnetic wave in a free space, the wavelength the lambda is equal to 0.20 meters. Wavelength is given. When the same wave enters in the perfect dielectric, when this same wave enters in a perfect dielectric, the wavelength changes, nothing but it's a lambda, wavelength changes as to 0.20 meters as changes to the 0.09 meters. Assume that mu r is equal to 1. Determine the epsilon. The first one they are asking that is determine the epsilon and the wave velocity in the dielectric, and wave velocity in dielectric medium. Okay. If it is a dielectric medium, definitely the conductivity is a 0. So the electric field, electromagnetic wave in the medium 1 is a free space. The wavelength in the medium 1, let us take it is a medium 1. Why I'm saying it is a medium 1 means whenever this same wave is entered the perfect dielectric, in a perfect dielectric, the wavelength is changes. In the medium 1, the wavelength lambda 1 is equal to 0.2 meters. 0.2 meters. While in the medium 2, the same wave it is entered the another medium, its wavelength is changes. It is lambda 2 is equal to 0.9 meters. 0.09 meters. Okay. In the both the medium, the frequency of electromagnetic remains is the same. Okay. In this both, the frequency is the same. Frequency is the same matter. So when the electromagnetic wave is the free space, the velocity of propagation is given as V is equal to. So V is equal to, actually it is the C. The frequency is the same, and the lambda, actually the F into lambda is there. That is approximately equal to the C. That C is equal to 3 × 10⁸ meters per second. Okay. The same frequency, the velocity. And they're asking that you have to find out epsilon and the wave velocity in the dielectric. And the epsilon also. Epsilon is very important here. When there is a two mediums, At one medium is the lambda 1 is equal to 1.2 and the lambda 2 is equal to 0.09. So let us take this by V1. The velocity V1 is equal to as a C 3 into 10 to the power of 8 meters per second in the free space, and F is equal to, in that if I am taking the F is equal to C by lambda 1, C by the lambda 1, the frequency. So we know the F lambda, velocity V is equal to F lambda, V is equal to F lambda. That V, I am saying that it is a C here, and F lambda 1. So I need the frequency, the F is equal to C by lambda 1. What is the C? The 3 into 10 to the power of 8 by the frequency at the lambda 1 is a 0.2. You can take it as a 1.5 into 10 to the power of 9 hertz. Okay, after we calculate 2 by 10, it is 10 power 9 will get 3 by 2 is a 1.5. Okay, my dear students. Now the electromagnetic wave enters in the perfect dielectric with the frequency. So here the frequency is lambda 1 is equal to 0.2. At that case, the frequency is 1.5 into 10 to the power of 9. Okay. And wavelength is lambda 2. Then the velocity is, what is the velocity now? With this frequency and the length of the wavelength is a 0.02, it is entered into the perfect dielectric. Now what is the frequency? What is the velocity there? That velocity is V2 is equal to F lambda 2. Okay, F lambda 2. What is the F here? 1.5 into 10 power 9, and it's medium 2, the wavelength is a 0.09. That velocity V2 is equal to, we got as 1.35 into 10 to the power of 8 meters per second. Okay, the V1 we got is a constant value. The same frequency for both the lambda 1 and the lambda 2, we use 1.5 10 to the power of 9. Now the second velocity, the V is equal to 1.35 into 10 to the power of 8 meters per second we got. But the velocity of propagation can also be expressed as V2 is equal to, you can also, by using this formula, you can find the 1 by under root of mu epsilon. Okay, 1 by under root of mu epsilon. The V2 we got as 1.35 into 10 to the power of 8. That is equal to, right, is implies that is equal to 1 by under root of, that is a mu naught and the mu r. What is a mu naught? 4 pi into 10 to the power of minus 7. They are saying that is a mu r is equal to 1, assuming that is a mu r is equal to 1. And we need to find the epsilon also. The epsilon is equal to. Okay, therefore, the epsilon is equal to, or under root of the squaring on both sides, the epsilon is equal to 1 by 4 to 10 to the power of minus 7 multiplying with 1.35 into 10 power minus 8 whole square, and for this only the whole square. Whenever it is a squaring, the square root get cancelled here. Thus multiply this epsilon and bring this value to the denominator. So the epsilon is equal to, we got the epsilon is equal to 4.9315. Okay, my dear students. This, like this, we can find out for the given values of the lambda and the wavelengths, different wavelengths. When we entered into the one medium to the other medium, assume the mu r is equal to 1, then you can find the epsilon and the wave velocity in the dielectric term. The wave velocity V2 is equal to 1.35 × 10⁸, and using that velocity, the epsilon is equal to 1/4 pi epsilon 10⁻⁻7 whole square. It is approximately, we got as a 9 point, not the 9 point, 4.9315. Got it, my dear students? Coming to the next example, my dear students. So the fourth example, we can check another example. Here you have to remember the concept and the formulas, my dear students. Exactly the same data in the examination. We did get the values the same, and they ask in the different way. But you have to remember how can do by using the given data and using the formulas. The concept is very important. To calculate the attenuation constant, they're asked that calculate the attenuation constant. Alpha is equal to, and the beta is equal to the phase constant. Calculate the attenuation constant and the phase constant of a uniform plane wave with the frequency, uniform plane wave with frequency 10 gigahertz in polyethylene, for which in the wave is traveled with this for which the mu naught is equal to mu and epsilon r is equal to 2.3, and conductivity is given. The conductivity is equal to 2.56 into 10⁻⁴ ohms per meter. See, the wave is propagated, or the uniform plane wave with a frequency of 10 gigahertz in a polyethylene, for which the mu is equal to mu naught and epsilon is equal to epsilon r is equal to 2.3, and the conductivity is also given. And you have to find out attenuation constant and the phase constant. Attenuation constant and the phase constant. So actually, we know the gamma is equal to alpha plus I beta. We need to find the alpha and the beta. They are not saying that it is a lossless. If it is a lossless, alpha is equal to 0 and the beta is equal to omega under root of mu epsilon. So directly you can substitute the frequency mu naught and the epsilon r. But they are given the sigma also. Sigma means the gamma is equal to, how the formula is there, that is j omega mu into sigma plus j omega epsilon. Got it, my dear students? So here the frequency is there, the mu is there, epsilon is there, and the conductivity is also. Then the real term is alpha and the imaginary term is a beta. So under root of j into omega, the 2 pi, into frequency, the 10 gigahertz into 10⁻⁹ whole multiply with the sigma is a 2.56 into 10⁻⁴ plus j into, again the omega is there, the 2 pi into 10 power 9. So 2 pi f, and epsilon. See here, I substitute only the j omega. Mu is also there. Mu is nothing but mu naught. That mu is a mu naught means so 4 pi into 10⁻⁻7 is also there. Here it is a multiplication factor. Total is multiplied with j omega epsilon. What is the epsilon? Is epsilon naught and the epsilon naught. Epsilon naught is 8.854 into 10 to the power of minus 12 and multiply with 2.3. Is whole multiplied, that is equal to, okay, my dear students, that the gamma is equal to. Now you can convert this as a function under root of j 2 pi, j 2 into 4 is 8 pi square, and here the 10 power 10 minus 7 is there, 10 power 3 multiplied with 2.56 into 10 power minus 4 plus j into 2 pi is a 2.3, 2 pi into here the 10 power 10 and 10 power minus 12. So 10 power minus 2 multiplied with 8.854 into 2.3. Okay, my dear students. So now calculate this value and multiply this, we'll get the j, means j coefficient is a beta, and calculate this value and multiply with this j square minus 1. So whatever the value is there, that is a real term, and convert the rectangular form to the polar form, or the polar form to the rectangular form, we'll get is alpha plus I beta. The gamma is equal to. By simplifying this equation, we got here the j, some coefficient will get plus j square into some coefficient will get, that is a under root of minus of some value plus j into the coefficient. Then alpha is equal to, by removing the under root of, means you have to find out this in the polar form. This rectangular form is converted to the minus x plus I into y, converted to the polar form, the magnitude and the angle. Then angle is a magnitude is under root and angle is a by 2. So alpha will get as alpha is equal to, in the Napier per meter is 0.0554 Napier per meter, and the beta, the coefficient of the j, that is a 317.84 radians per meter. Okay, my dear students. That is, they ask what is the alpha and the beta for the given attenuation constant, and the beta is equal to phase constant. For the given frequency 10 gigahertz in a polyethylene, for which the mu is equal to, consider as a mu naught, and epsilon r is given. So epsilon naught is there, 8.854 into 10 to the power of minus 12, and substitute all the values and simplify. The real coefficient is alpha attenuation constant, and imaginary coefficient is a phase constant. That is alpha we got as 0.05 Napier per meter, and beta is equal to 317.84 radians per meter. Got it, my dear students? This is example 4. All in this, the formulas is a very important, my dear students. See, the first example, alpha is the lossless, means alpha is equal to 0. Alpha is equal to 0, and beta is equal to omega into under root of mu epsilon, and the lambda is equal to 2 pi by beta, and eta is equal to under root of mu by epsilon. And coming to the second example, in that second example also, the beta is the same magnitude lambda, the wavelength is the same, and the velocity is there. The velocity V is equal to F lambda. And intrinsic impedance is under root of E by epsilon. And the intrinsic impedance in terms of electric and the magnetic field is the ratio between of EM plus by the HM plus. Okay. Coming to the third example, they're asking that for the given the medium 1, there is a velocity, not the velocity, the wavelength is the 0.2 and the another wavelength is lambda 2. When it is a travel from one medium to the other medium, what is the velocity and the epsilon? The first one is the velocity is 3 into 10 to the power of 8 is a constant value. Then after it is moved towards another medium, that velocity changes when the wavelength is also changes 1.35 into the power of 8, and V2 is equal to 1 by under root of mu epsilon. And coming to the fourth example, the gamma is equal to j omega mu sigma plus j omega epsilon. Substitute all the values and find the alpha and the beta. Got it, madam?